We're now going to do a demonstration of using R Markdown to document our analysis of the course data set. But this is exactly the same process you would go through to document any analysis you've carried out using R and RStudio. All right, so let's head over to RStudio. This is the project for the course. You're familiar with opening this. I've downloaded two files, the R Markdown Essentials, an R Markdown template, and a third file, the Flexible Dashboard Essentials. Okay, these are all on the lecture page for today. Before we jump into the main script for today, which is the R Markdown with the essential code chunks already put into it, I want to take just a minute to show you what I highlighted in the slides, which is I can easily start any new R Markdown document by going new and scrolling down and choosing that R Markdown document from the new list. It'll then ask me if I want to document. Yes, you can actually make R Markdown presentations or choose one from a template. We'll get to that later. But I just want an R Markdown document. I can title it here if I want, and I can choose the default output, whether I want it to be HTML or PDF, or for reasons beyond me why you would want to compile to Word. But we're going to just leave it as HTML. I'm not going to title it. And we start that new document and we get exactly what I showed you in the slides. A simple YAML header, a basic code chunk, and some text. Okay? An additional code chunk here for R showing a summary of a data set that's loaded in R all the time, an example of how to plot. And remember what I said, a good rule of thumb, an important rule of thumb, is that you have each code chunk producing only a single output. In this case, a summary of a data set, a plot of a data set, and that's really it. Okay? You have some markdown here with bolding of a word, a link, and more. One thing you'll notice that's a default when you start a new document, and it's a useful thing, is a single line of code in a first code chunk called setup. And I always have a code chunk like this in my document. You'll see it in our course document where we have a code chunk called setup, and we've set an option include equals false, which means neither the code nor the output from the code will be shown in the final compiled PDF or HTML document. Why? Because I'm using this setup code chunk to set some global options that'll be applied throughout the rest of the Markdown document. And that is, I want to use knitter's option chunk options to set echo equals true or false or whatever. Basically, it saves me from having to put the same arguments in every code chunk header. If I use the same thing all the time, I can set those as defaults right here. And then if I ever arrive at a code chunk where I don't want this to be the case, I can toggle that off or change it in the options for that specific code chunk. So it's a way to set global options that will be applied to all the code chunks beyond this. Okay, I'm going to close that document now. And now I'm looking at the R Markdown document for the course. First thing you'll notice is a more substantial YAML header. The YAML header, again, is marked by these three hyphens. But now we have a more substantial title. And I've indicated using, again, our syntax here, that I want this title to be centered. I also have now an author line and a date line. And I'm indicating that, again, I want these things to be centered by bookending this with centered. And I'm also now, you're seeing the first example of inline R code. Remember, primary purpose of an R Markdown is to have code chunks, but I mentioned in the slides that introduced this topic that you can also have inline code evaluated. Instead of 3 tick marks opening and closing a code chunk, inline code is bookended by a single forward tick, the language that is being used, and then the actual code that you want run. So this is my way of stamping a date on the top of the document without having to guess at the date. It just takes the system date from my computer. Okay, and I could do the system time, whatever you want. But this is an example of an inline bit of R code that can be evaluated anywhere throughout the document. And we'll see other examples of that and where it's really useful beyond just kind of making a pretty cover page later in the Markdown document. I've also said, that there could be two potential outputs here. There could be an HTML document, and I put that first. And I have a bunch of different sort of details specified about how I want that HTML document to look. Whether I want code folding as an option, what theme I want. Theme will include the fonts and colors, much like themes to ggplot graphics. Whether I want highlighting, whether I want a table of contents, and if I want that table of contents to float as I scroll down the HTML page that it will make. So this is just an example of all the ways you can kind of control what this document will look like when it gets compiled. Again, none of this YAML header will be displayed in the final document. And then if I create a PDF document, I would still like a table of contents. So you can set options for both. All right, now the code chunks. We again see this typical code chunk structure. And you can see that I have this setup code chunk just like the default R Markdown document had that we made just a minute ago. But I have a few things in here. I have not just one global option, I have three. I never want messages displayed, I never want warnings displayed, and I always want the code shown. All right. Now, I put include false equals false in this, so this code will not be shown. I've overridden those global options for this code chunk. All right. Now, I've got some text, right? And I'm not going to belabor this, but I described the course and the data set we analyzed using, the syntax we've talked about, adding hyperlinked words and making things bold. And I've got a level 2 header. That level 2 header shows up here in my table of contents, as do the names of my code chunks. We'll get to that in a minute. Okay, so code chunk 1 is called setup. And that's because code chunk 1 has a title immediately after the indication that we're using R with no comma separating it. It has just the title of the code chunk. So that now appears in my table of contents. As I scroll down, I have an additional syntax bit here of 3 asterisks. Will make a horizontal line demarcating. It separates some of this text. It'll make a nice looking document. I can do that throughout or only when I feel I need it. I have different levels of headers. Again, these show up as different levels in the table of contents. So read mapping has a aligning raw reads with Callisto subheader under it. And there it is. Read mapping aligning raw reads is now indented, as is importing count data into R. All right, I talk about the tools we use. Again, I'm not going to go over this, but then we get to our first essentials code chunk. And that code chunk is R. I say it's step 1, and it's using TX import. And it's doing all the things we did in these first essentials from the step 1 script. I just copied the essentials and pasted it in here. That's it. That will produce really no output because TXI gene is just what we're creating. So the code will be shown, but there won't be a figure embedded below that code. No figures produced. I then move on to the next step, pre-processing, and I look at the impact of filtering and normalization. This is the step 2 script. It's all the essentials from the step 2 script, just pasted in to this code chunk called step 2, data wrangling. I don't need to worry about setting options because I set those global options up above. As you scroll down through, now this is an example of where we need to just create one output, right? When we went through this, actually demonstrating it in class, we produced each ggplot of raw distributions, filtered distributions, and normalized data. But now it's important that this code chunk produce a single output. So I've stored each of those ggplot objects and I call on them later using the cowplot function. And this is all in that essentials code chunk. And I tell it to make a single figure with all 3 of those graphs. Okay. Now, outside of a code chunk, we're just talking a bit about what we've done. We say that filtering was carried out to remove lowly expressed genes. Basically, this is a more human readable way of talking about what we did, how we set our filtering. But now we see another example of using inline code and using it in a way that's really advantageous. So I'm saying that the filtering that was carried out reduced the number of genes from R measure the number of rows of my DGE list. 2 are the number of rows of my filter DGE list. What this will do is when the final document is compiled, we will get the exact number of differentially of data, of genes in our data set, or transcripts if you read your data in at transcript level, before and after filtering will be printed right here, right? This code will be evaluated. That's incredibly useful because if you ever go back up in this code and change the criteria by which you're filtering, you won't have to worry about whether you got it right in terms of the number of genes that you've listed in your final document or in your figure or in your methods or anywhere else in your manuscript, because you'll just be able to count on this number being accurate because it's derived directly from the objects in your R environment. Okay, then we go into the step 3 script, and this is an example of where we had to split the essentials across 2 code chunks because the step 3 script, even the essentials code chunk, produced 2 outputs, a PCA plot, maybe 3 outputs, a small multiples plot if you decide to generate that. We don't have that in the essentials. And also a table. So let's just take a look at this quickly. We've got the first part of that step 3 script, and we're creating now an interactive graphic, okay? So we're creating that PCA plot. Then we have another code chunk that is producing a data table, okay? That's really the step 3. Now we move on to step 5 and on and on. And in step 5, we produce multiple outputs again, volcano plots, tables of differentially expressed genes. So we have to spread that essentials code chunk out across multiple R Markdown code chunks. And again, if we're going to make multiple graphics, we need to store them. Or if we want those graphics to be interactive, we need to assign them to an object and then pass them to ggplotly. So the sole output from this first part of the step 5 code chunk is an interactive volcano plot. Then tables of differentially expressed genes, heat maps and modules, and on and on. All right, all the way down through differential gene expression and Go enrichment and functional enrichment analysis using GSEA. Okay, so the functional enrichment analysis bit of essential code chunk really does have to be split in many ways because you're carrying out Go enrichments and making plots of that. You might make tables. You might make GSEA enrichment curves. Similarly with the heat map, you're going to cut out different modules. So you really have to think, especially towards the end of this R Markdown, about what is this code chunk going to generate as the output, and make sure that you really have a single clear output from each R Markdown code chunk. All right. If you want to try this on your own, you can use the R Markdown template, which is basically this with all the code deleted, but the title's still there so that you can kind of work on constructing it yourself. But once I'm happy with what I've created, I can click on knit. And because I've said I want this document compiled as an HTML document, that's going to be the default. When I created this document, remember the pop-up window from RStudio said, what do you want this to compile as by default, an HTML or a PDF? Mine is set to HTML. If I wanted to force it to compile to a different one, I can do that by clicking the drop-down menu. But I just want to go ahead and knit this, meaning I want to run the code, generate the outputs, and have knitter, the R package knitter, pull together those outputs and put them into a final document that will be rendered in HTML. Now, of course, this means you're going to need these packages that are indicated here, which we haven't really used thus far in the course. So the R Markdown package, the tiny text package, and the knitter package. So if you don't have those, go ahead and pause the video, download those, and you'll be ready to go. Unlike our R scripts, we don't need to go ahead and load all these packages. They're going to be loaded as the document's evaluated and each code chunk is run. Okay, great. I think we're ready to go. So we're going to go ahead and hit knit. And this process can take some time. It's going to open up a new window called R Markdown that's going to now step through each code chunk, and it's going to show me progress as it goes. Now, this only takes about a minute, but rather than sit here, we're going to do the cooking show approach. And I have already generated this document. It's actually sitting right here, R Markdown essentials.html. So it takes the name of your Markdown document and creates the output of the same name of either HTML type or PDF. So if I click on that and open it in the browser, I get this. I'm going to zoom in just a little bit, just so you can see. So this is the output, right? That R Markdown document generated a scrolling HTML file. That floating table of contents stays with me. That's why it's floating. And I can see my status, where I am in the document as I go down. So let's look at what happened when we ran a code chunk, right? When we imported data into R, that first code chunk, that generated nothing, right? No outputs. But I can see how that data was generated, how those reads were read in. So this is valuable for the reader to see this code, but it doesn't produce an output. I can see the hyperlinks that I set up. What I don't see is that first code chunk that actually set the global options. Remember, I said include equals false. And I can see my sort of, the syntax that I used. I can see the what you see is what you want aspect here, which is I get this nice table of contents with headers appropriately structured. As I scroll down, I see, me running the filtering and the normalization, and I get the output from this code here. I then produced a PCA plot, which gave me the data here. I have a table of all my data here, a volcano plot that's interactive, and this can kind of slow down your browser a little bit because there's a lot of data points on this volcano plot, but hopefully yours displays okay. But I get all these mouse over tooltips. So this is the great thing about compiling to HTML, is all of these interactive graphics we generated are all able to be used in this HTML document. And this is a single file that you could email to somebody. It's not that large of a file, and they will be able to peruse this data, not just understand how you generated these graphics, but actually be able to interact with them as well. Same thing, if we produce tables of differentially expressed genes using the data table function, those tables are all searchable. They can all be scrolled over and looked at, filtered, sorted, changed in lots of different ways, okay? All directly within the document. We have our heat maps, and unfortunately in this iteration of the course, we had trouble with the interactive heat map functions from heatmaply and D3 heat map, or else this heat map would be interactive as well, but that's okay. We grabbed our modules, and we carried out Go enrichment, producing interactive Manhattan plots, which also can kind of be hard for your browser to display. Enrichments for the genes that were upregulated and downregulated, and then our GSEA results, any GSEA enrichment plots you want to show, and summarizing those as bubble plots. Remember, we always end by running session info at the end, and now I know exactly what version of R, my platform, the operating system, and all the packages and their versions that I used. Okay, really maximizing transparency here in the way I do the analysis. The last thing I'll show you is that if we find a bit of inline code up here, you can see as I call a piece of inline code, I didn't have to worry about this number. It was auto-generated. Okay, same thing up above as well. Again, my browser's having trouble with the volcano plot. Yours probably will too. It's just a lot of data to display in the browser. Okay, and here it is finding my filtered genes. My filtering took the data from 35,000 genes to 16,000. All right, the other thing I should highlight is in the YAML header, we said we wanted code folding, and that code folding is something we can do at each code chunk, hiding the code or showing it, but we can also hide all the code. And that makes for a document that is basically a lab notebook, right? Where we have the ability to read what was done and why, and the data that resulted. And if somebody wants to see the code, they can. So this is a great way for you to customize your R Markdown HTML in a way that you may send it to people for different audiences, right? So maybe you're sending it to your PI who doesn't care about the code, and you want to hide all the code. If you send it to a peer of yours who's really into doing R, they could easily just show the code and observe it. And you can set whether the code is folded or not by default in the YAML header. All right, so that's how we make an R Markdown document. In the grand scheme of things, this is ultimately an extremely useful thing to do. But there are times where you might want to make a slightly different version of an R Markdown document, again, depending on who your audience is. And so I want to illustrate sort of two things. One is how to make this not an HTML, but a PDF. So our R Markdown document just finished compiling. So I'm just closing that. It clearly took a couple minutes, but that's fine. So how would we change this if we didn't want an HTML? Maybe we want to include it as a supplementary file, as I just showed you in the slides, as a PDF. How would we compile to PDF and what would need to change? If we just went to knit and we said knit to PDF, we're going to get an error. And we're going to get an error because we have some objects that are interactive that would need to be removed. And it's not hard to do. You basically have a situation where you're using Plotly. Oops. You're using Plotly in this code chunk to make your interactive PCA plot, here to make your volcano plot, and here, those are the two places, PCA plot and volcano plot. Those would just need to be changed, basically removed, the ggplotly command, so that you just generate a static plot. You're also using the data table function to make interactive tables here and here and there. And those would just need to be, either change the whole code chunk to eval equals false, or delete this data table function altogether. So you want to go through and remove anything that produced an interactive graphic. Once you've done that, then you can go back to the top, you can knit to PDF, and it will make a PDF document, and that PDF document will look like this. All right, again, a lot of the elements that we saw in the HTML are here, but we have some advantages and disadvantages of compiling it this way. We still get the clickable table of contents, but what we don't get is any interactive graphics. We also have this added issue of long strings of text or code run off the PDF. They don't wrap. I actually had a reviewer request that our supplementary code file not have anything running off the side, so I had to go back. It wasn't that big of a deal, and just kind of guess based on what I saw in the PDF where I needed to hit return in the R Markdown document to make sure the code wrapped down. So that's just something to consider. It also, the other disadvantage of PDF is that you have page breaks, right? Stuff has to fall on one page or another. It can't fall on both. So those page breaks can create awkward, spaces at the end of a document where the volcano plot ended up going on the next page, and they can create for some unusual sort of scattering of your figures across different pages. All right. The other interactive, of course, you would have to remove is you'll have to change the ghost plot to be a static ghost plot using the publish ghost plot function. We did this in that bit of the course where we changed the interactive to be false, and then we set this to publish ghost plot, and that's what you would have to do. All right. So those changes allow you to make a PDF. What about the last thing I mentioned, this idea of a flexible dashboard? So it's just a way that you can access all kinds of different R Markdown templates. And this particular option is available here under the R Markdown document. Whoops. Let's do new R Markdown and from template. And now if you have installed the Flex Dashboard R package, which you should do in order to do the next step of what I'm going to show you, you should see the Flex Dashboard as an option. And the Flex Dashboard, you can think of it as an R Markdown that compiles to a data dashboard where the focus is on graphics and interactives and not on the code. So what does this look like? If we go up to the Flex Dashboard Essentials, It takes a little bit of getting used to, but it has a YAML header, which you're familiar with. It has this setup code chunk, and it really is structured in the same way as any R Markdown. It has code chunks, demarcated in the same way. But what's different is we don't have text description outside of those code chunks. Okay, we're not using the dashboard to talk to the reader or viewer. We're using the dashboard to communicate visuals to the reader or the viewer. What we have outside of the code chunks instead are simple titles and some syntax that indicates the layout of the dashboard. In other words, the data that's generated, the outputs, if we scroll down to, so this output, the plots being made to show the distributions, I want those as one element in a row on the dashboard. All right. Also included in that row is the next graph, the normalized data, and also included in that row is a PCA plot. Then I want a new row that includes a table, it looks like. So I decided to put a table here of all my data. Then I want a new page of the dashboard that's a tab. And I want a column now, not a row, that has a volcano plot, and on and on and on. So you can take a look at how I've laid this out. But when I hit knit, because it's a flexible dashboard template, it's going to knit to HTML. It only knits to HTML. And when I finish that, it pops up and gives me this. Remember, I said that these dashboards take the emphasis away from reading and instead put the emphasis on the visuals where the code is actually hidden. It's not unavailable. You can click source code and see all the code that was used to generate this dashboard. So it still maintains that transparency, but it gives us this different look and feel. So remember how I said I had my data, then the normalized filtered data, then the PCA on a single row of the first page? Here it is. The next row was dedicated entirely to the table because it's kind of wide, so I gave it its own space. But then I set up another page that, again, some of these can take a while to load. They're just loading in my browser. But another page that was set up as columns where one column was just my volcano plot and the other column had a tabbed structure to it where one tab is my differentially expressed genes and the other tab is a heat map of those differentially expressed genes. And again, if our interactive heat maps worked, the interactivity would be evident here. I then have another tab on my dashboard. This is very topical, my overview, my differentially expressed genes, and now my functional enrichment. And I now have this long Manhattan plot of my terms that are enriched in disease. So the genes that had gone up in my heat map, if I go back, these genes. And if I take a look, then in this page of the dashboard, I also have a tab for things enriched in healthy, or the genes that were higher in the healthy patients, right? Good intact skin, and the searchable table of those as well. And this, you could have additional tabs here. Those icons that you see are all dictated by the fact that I've told it I want a particular icon from Font Awesome, FA. So it's an open source font system. Easy to find an icon on their website and say that you want a data icon with the overview tab, which is what we see here. The overview tab has that particular icon associated with it. Okay, so very easy to make dashboards. The transparency is still there, but the look and feel is very, very different. All right, I think now you have some good examples of how to make R Markdown documents of PDF, compiled to PDF, compiled to HTML, or even making your own data dashboards. So good luck in making your work as transparent and reproducible as possible. In the next class, the next lecture, we'll pick up with how to actually combine these concepts with Dockerized tools for making not just your code transparent and reproducible, but also your computing environment. See you next time.